Define Pascal's law. Describe the relationship between hydraulic force and the surface area of an actuator. Explain how the volume of fluid in a hydraulic circuit affects energy transfer. The theory of hydraulics, as demonstrated by Pascal's law, applies to hydraulics system throughout the Gini lineup. The basic concepts of Pascal's law include compressibility of gases, incompressibility of fluids, equations for force and pressure. Pascal's law also states that a pressure applied anywhere to a body of fluid causes a force to be transmitted equally in all directions, with the force acting at right angles to any surface in contact with the fluid. This cylinder is filled with gas. As weights are dropped onto the top of the cylinder, notice how the gas becomes compressible. This cylinder is filled with liquid. As weights are dropped onto the top of the piston, notice how the liquid becomes pressurized. As you can see, fluid is not compressible. The cylinder shown is filled with fluid. When a marble is dropped into the tube, a simple hydraulic system has been built. Select the arrow to the left of cylinder to apply force to the system. Based on the observation, fluid can transmit motion. Now that you have seen how fluid can be used to transmit motion, let's look at what happens when force is applied. By selecting the arrow, force will be applied to the system. Observe how the fluid transmits the motion and force from one piston to the other. Based on this observation, fluids can transmit motion and force. When force is applied to the fluid, it becomes pressurized and transmits the force equally in all directions. To understand the principles of hydraulics, it is necessary to know the meaning of the terms force, pressure, and area. Force is that influence on a body that causes it to move or accelerate. Pressure is a type of stress which is exerted uniformly in all directions. Area is a measure of the size of a two-dimensional surface, or region of such a surface. Earlier in this lesson you learned that fluid becomes pressurized as a result of the force applied to it. The amount of pressure in a confined space can be determined by using a mathematical equation. The equation to calculate pressure is force divided by area. In the figure shown, a 10-pound force is acting on a 2-inch area. To calculate pressure, you would divide the force of 10 pounds by the area of 2 square inches. This gives you 5 pounds per square inch, or psi, throughout the container, acting equally on all surfaces. A simple, yet effective, chart can be used to calculate force, pressure, or area. Let's say you want to calculate the amount of force that a cylinder would supply. Covering the force area would give you pressure times area. How about calculating pressure? Covering the pressure area would give you force divided by area. And finally, how about area? Covering area would give you force divided by pressure. Let's try a simple exercise to illustrate a point about the relationship between force, pressure, and area in a hydraulic circuit. In this example, the circuit pressure is 100 psi. Using the drop-down box to change the surface area of the piston. Notice that when the surface area of the piston increases, so does the force that is created. This means that 100 psi of pressure can create a very small amount of force or a very large amount of force, depending upon the size of the piston. Let's try another exercise to illustrate the relationship between force, pressure, and area in a hydraulic circuit. In this example, the surface area is stable at 10 square inches. Using the drop-down box to change the force applied. Notice that when the force increases, the pressure also increases. In this last example, the force is stable at 5,000 pounds. Using the drop-down box to change the pressure. Notice that when the pressure increases and the force stays the same, the area also increases. Force is applied, transmitted, and produced in a hydraulic system. In the previous topic you learned that surface area and force are directly proportional. The larger the surface area, the greater the amount of force produced. Hydraulic circuits are designed so that a small amount of applied force can produce a large amount of output force. This concept is referred to as hydraulic force multiplication. To understand the concept of hydraulic force multiplication, you must understand the relationship between force and area. A relatively small amount of force applied over a small area is equivalent to a much larger force applied over a small distance. This is how we can create hydraulic leverage. By selecting the arrow, notice how the applied force of 100 pounds creates an output force of 1,000 pounds. This animation shows another example of force multiplication. A force of 10 pounds on a 2-inch tube area can be transferred into a force of 20 pounds on a 4-inch tube area. The pressure of 5 psi remains the same throughout the hydraulic circuit. This type of force multiplication is what makes hydraulic systems so effective. By manipulating the force, pressure, and surface area, engineers can create highly efficient circuits able to produce a great deal of work. By now you know many factors that affect design of hydraulic circuits. For example, you know that pressure exerted on a large piston will create more force than same pressure exerted on a small piston. There is a trade-off between force and distance. Less force exerted over a large distance is equivalent to more force exerted over a small distance. There is one key component left to discuss: the speed of energy transfer. The speed of energy transfer refers to how fast work can be done. In the world of mobile hydraulics, this refers to the rate of speed at which the hydraulic functions operate. Energy transfer is a function of both system pressure and rate of flow. By now you are familiar with system pressure. Rate of flow, however, is a new concept. By pressing the slow and fast buttons, we can see how the rate of flow affects the speed at which the cylinder is extended. The rate of flow is measured in gallons per minute. In this demonstration, the cylinder on the left-hand side is acting as the pump. The rate at which the pump displaces fluid through a hydraulic circuit directly impacts the speed at which work is accomplished. The more fluid displaced through a system, the faster the work is accomplished. This simplified circuit depicts a pump, an actuator, and a control valve. By increasing and decreasing the speed of the pump, the flow of the fluid flow will be affected. Watch how the volume of fluid in the system affects fluid flow in the cylinder.